for this, some technical problems. Okay, so yeah, my name is Paweł Łabaj, and from Krakow, Małopolska Center of Biotechnology, and I would like to tell you a bit of our project. I mean, I was presenting preliminary results 2 years ago, and now the project's over, so it's time to show what we did. But to start this, we started, in fact, a few years ago, about a decade ago, the question, is there good in principle? And this was the motivation for Chris to go around with his students the New York City Metro, and they check what's living there, because at that time there was in fact no answer. I mean, we have completely no idea what's living around us. So they collected the data, a few thousand samples in the New York Metro, and they figured out that, first of all, majority or almost majority of what we're finding, we have completely no idea what is it. I mean, it's not annotated anywhere. And in fact, it's not changing in different cities. It looks very similar. They also found plenty of pathogens, but at a very low abundance. So in principle, Chris has said once, I think on TEDMed talk, that he would advise any new parent to roll its child over the dirt of New York Metro, which is a bit of controversial immunization approach. But let's say that more or less at the same time, the Jack Gilbert and Rob Knight have said the same in his book, The Dirt is Good. So this is a book dedicated for the young parents. But okay, so it can be good, but the question is whether it can be useful and how it's different across the world. So this is what we're doing in the MetaSub consortium, which has been set up in 2015, and since then we are collecting the samples in the public transport on every year on 21st of June. So it's already a decade now. And like in Krakow, also yesterday we combined with the European Games. So we are collecting a lot of data, and those data need to be analyzed somehow. So there is like a sister COSI CAMDA, which is starting on Monday. And in CAMDA, we took advantage of those very rich data set which we had from the MetaSub, and we start asking the questions. So in 2017, the question was, can we differentiate between the cities, US cities based on the microbiome composition? And there was no, decision how the people need to analyze data. And the answer was, of course, yes, it's pretty simple. So then in the next years, we started, like 2018, we added more samples from all over the world, from all continents. And again, the question was, can you classify, if you have a new sample, can you classify from which of the known cities is coming from? And the answer was, again, it's working pretty well. The difficulty started later when, in fact, we're asking not only about the classification, but also about the prediction of the origin of the new mystery sample. But overall, we have learned a lot from the CAMDA results, simply that there is a city-specific microbiome profile. And in fact, the old approaches works well. I mean, it doesn't matter whether you're doing the first taxonomical composition identification and then you apply some AI to distinguish, or whether you first also want to look at the functions, or if you do not care at all, that you're just using, okay, those are my data. If I want to classify different samples, I don't need to know the taxa, I don't need to know the functions, and I'm just using the bag of words or the k-meres. All works good. But on the global scale, it appeared that multilateration is not working. So I cannot take 3 points and then I can predict that like composition of those 3 will be somewhere in the middle. It's not working like this. And here the effect is that this Earth, continent, oceans, climate, or ecological niches are really influencing what's living in a specific point. So that's why you cannot predict. Also, there were some odd misclassification like New York and Lisbon, or the Tokyo and Auckland. But when we look into the global map, we discover that they are very similar, let's say, environmental area, and they're almost exactly the same distance from the equator. So it was like a bit of very rich information for us. And more or less at the same time, the MetaSub paper has appeared after a few years. So we analyzed almost 5,000 samples from a few years of the sampling days. And what was important from the perspective of this talk was that the urban microbiomes echo important features of the city and city life. So if there are features which are connected with the city, it's affecting microbiome, and it caused that it's possible to distinguish between different cities. And even the very simple classifiers are working well. So it led us to thinking about, can we use it in forensic, because microbiome is used in forensic already for a long time. I mean, a classical approach is like the dead body decomposition. It's what microbes you can find. It allows us to tell when the person was killed or died. Other approach is just to identify the person microbiome. I mean, the studies of our colleague from Hong Kong is showing that if you will be coming to this room for 3-4 consecutive days, even if it will be cleaned, then after 3-4 weeks, we can still identify that you were here because you're living your microbiome. But the third approach was, okay, whether we can use like the dirt, the soil microbiome to trace and to predict from where the sample is coming from. And this was, in fact, our question in the soil microbiome analysis forensic tool project, which was done under the lead of the Central Forensic Laboratory of the Police and with a couple other partners. And the thing is that looking into the Poland, we wanted to make a system which will allow police to classify from where the specific sample is coming from. And the Poland is pretty difficult country because, if I could remember, it's third or the fourth most circular country. So it's very interesting from this point. There's also very homogeneous in terms of the elevation and everything. So in principle, we have everywhere almost exactly the same climate. But we thought, okay, so we will sample the soil from all over the Poland, but maybe we can find some subtle differences. So we analyzed 20 years of the climate weather data, and we found out that in fact we can distinguish 3-4 different subzones, and we sampled through them. So we sampled 80 locations. In each location we collected three samples, and we were collecting the samples over the 4 seasons. So in the end, we ended up with almost 1,000 samples. Each of them was sequenced with over 100 million reads, so pretty deep. In addition, we had tons of metadata collected at the site, like photographic, descriptive information using the COBO toolbox. Also, on the spring season, we collected a bit more of the soil. We did the physicochemical analysis, like the metal concentrations, the water, pH, and so on. And we have this weather data from the Open Weather Map. So we have those tons of the data, and we wanted to make this system. So because it was for pure forensic purposes, we decided to go with the KML-based approach. That's why we used the metagraph solution. So simply from every sample, you're creating a graph. You're merging all the graphs, and you're looking the location-specific, the unitics. So the stretches of the nodes, which you can combine into some sequences. We used our SMAF data as a positive sample and the MetaSub data as a negative because we wanted to make our solution Poland specific. So we had this the graph from the SMAF, from the MetaSub. Then we just merged them together, look for the differential subgraphs, and this way we have defined the tones of the unitics, which later went through the further relevance selection. And once we had those sequences, they were used for two folds. One thing was to get our reference data, so abundance of our features, and the second, they were used for designing the targeted sequencing panel. So it was in this case the Roche approach. So interesting, what we found in our final panel is that among the about 1,000 features which we decided to put on it in the end, about 40% of the targets, so 40% of the sequences, they are coming from the at the moment not yet known organisms. So this was in fact, for forensic purposes, is good feature, good thing, because if somebody would like to bias the trace, then they don't know how, because they don't know which bacteria should be used to bias the trace. On the right-hand side, you see the comparison between this whole metagenome sequencing and this targeted metagenome sequencing. So you see that the agreement is pretty good. Typically samples looks like the above panel, and the worst samples looks like the below panel with still pretty good concordance. And remember that whole metagenome is over 100 million reads, while the targeted sequencing is just about 1 million. So the agreement is pretty well. And once we had those targeted data, we used the following scheme for the classification. So when the new sample is coming, then we, based on the panel sequences, so we calculated the abundance, and then using the triplet loss and the DNN classifier, we're getting the new sample classification results. And overall, we got a very nice performance. Unfortunately, it's cutting a bit of the top, but in the training, so what we were using is that in the training we had our whole metagenome sequencing abundances from the 4 seasons. So there's 947 samples, but in the validation was done already on the targeted sequencing from the selected set of the samples, over 300. And you see that it doesn't matter really which metrics we are using, the performance is really good. What you see on the bar plot, that you see the drop for the third bar, which is the third season, which is the spring. And it was a bit surprising for us because the panel was designed based on the for the autumn, winter, and spring data. It was not designed based on the summer one. So we thought that the worst performance would be on the summer, but in fact it was the spring. But thinking more about this, I would say that this is a bit what you would expect, because the spring is the time that most things start happening. Yeah, the vegetation time is starting. So overall, the rock curve looks really nice, and it looks also very nice for the second on the second figure when we had the mock forensic approach. It was that we took the soil, put on the sole of the shoes, jeans, and then either keep it in the room temperature or in the fridge or in the heater for 1 month, for 3 months, and so on. And then we do all the analysis. So it was like simulating the forensic cases, and it looks very good. So to summarize, we had the big data, so the deep whole metagenome sequencing, and a lot of samples. We used the metagraph for identifying the unitics and the Boruta for selecting relevant features. Then we create a panel, and we use the probe-based targeted metagenomic sequencing. And we use the CMC neural networks and dense neural network for the classification. So overall, it performed extremely good during the validation, but also very good for the mock forensic. And in fact, already for like half a year, the complete system is at the disposal of the Polish police. And what is, I think, very interesting, and it's nice work maybe for the future, is that as this approach works in as homogeneous country as Poland, it will simply work everywhere. So this is my team. So the Vitek and Kinga, they had posters already about the different things which we do at the in our lab. Kinga is also going to have a talk on Monday during the CAMDA. So thank you for your attention, and I'm happy to answer your questions. Just please use the microphone, because my hearing aid died today in the mornings and I'm a bit deaf.
Thank you. Just one quick question. Yeah.
I'm also working in the forensic application using DNA metabarcoding of pollen. I was wondering about have you ever seen any differences between the soil features like sand, silt, clay differences? I don't know how the surface soil in Poland, but you will see distinct differences in terms of the microbiome composition.
I mean, we were not looking into this yet, but we have those information. I mean, looking into like clay, sand, and so on, it's interesting, but you need to collect more just to do all the physical chemical analysis. With the microbiome, you can have just really a small, tiny trace which you will take from the jeans or the shoe, right? But I think this is tons of very interesting data, and a couple of my team members are investigating further. So we also will look into the soil type, like whether it was clay or whether it was the sand. So this is something very interesting, but it was not the purpose of this project, but this is something which definitely will be on our radar for the next months or maybe even longer.
Thank you so much.